Kia ora Year 13. This is question 2 from last year's probability concepts exam. It's all about students snoring and how that affects their performance in exams. I've got to say, pretty boring context, but there you go. So let's read through it first and see what we're asked to figure out, and think about whether we're going to use a tree or a table or a Venn diagram. So it's suggested that snoring at night has an effect on student performance in examinations. Data was collected on whether or not a group of Year 13 students gained achievement or better in their final exam. And it was found that for the 123 snorers, 91 gained achievement or better, whereas for the 78 non-snorers, 68 gained achievement or better. Then we're told that a student is randomly selected from those in the study, and we're told to define S as the event that a student is a snorer, and E is the event that the student got achieved or better. We have to compare these two probabilities, so this one and this one. So the probability of E given S is a conditional probability. This means that if we know someone is a snorer, what is the probability that they got achieved or better? And this is the unconditional probability, just the probability that someone got achieved or better. So you can think about this as if you put all of the names of the students into a hat. This is everyone, and so that's where we're going to find the probability of E. And this conditional probability is if we put only the names of the snorers into the hat. And in each case we pull out one name. So, if these two things are independent, then the probability of someone passing is the same as the probability of someone passing if we know that they're a snorer. Okay, so this is one way that we can test for independence. So what we're going to do is we're going to work out this probability, and we're going to work out this probability. We're going to see if those numbers are the same. So what I'm going to do that is to build up a table. Now I'm partly doing that because I've skimmed through the rest of the question. So we'll have a look at that now. What else is in here? Well, we have to figure out how the risk of not achieving in the exam compares for those who snore and those who don't snore. So this is a relative risk question. A table is going to make that one very easy to work out. And then in part 3, we've got more stuff. We've got students who snore and whether they finish their homework or not. So this is probably going to be a tree diagram, but we can start off with a table. So let's go back to the start. Okay, so setting up a table, what I need to do is to take those numbers and plonk them in the right places. So let's do it like this. Here we're going to have students who snore and students who don't snore. Here we're going to have students who pass. I think that's what E is. Yep. And students who don't pass. So the first thing that we can do is to say that we had 123 snorers and we had 78 non-snorers. Right. Next, we know that 91 of the 123 snorers passed. So we can put 91 on here. And we know that 68 of the non-snorers passed. So as usual, we can fill up the rest of the table pretty easily. And we may or may not need all of these numbers, but that one's going to be 32, this one's going to be 10. These two add up to give me 42 here, and these two add up to give me 159 here. So in total there were 201 Year 13 students who were surveyed. Okay, now we have to work out these two probabilities. The probability of E given S is equal to 91 out of 123. So I'm just choosing from the snorers. Turn into a decimal, that gives me 0.7398. And now the probability choosing out of everyone that they pass is 159 out of 201, which is equal to 0.7910. So, since the two probabilities are different, we can say that the events S and E, so the events snoring and passing, are not independent. What that means, and that's all you had to say for the question, but sometimes you might need to explain that a bit more. So here's one way to do that. What we're saying is that if we know that someone snores, a year 13 in this group snores, knowing that someone snores should make a difference to what we think about the probability that they passed. So should affect our estimate of the probability or of how likely they are to pass the exam. Okay, so that's the first part done. Let's see what's next. Right, estimate the risk of receiving not achieved in their examination, or estimate how the risk of receiving not achieved in their exam compares for year 13s who snore and year 13s who don't snore. So first I need to work out this, and then I need to work out this. And this one is from my table 32 students out of 123, and this one is 10 students out of 78. Turning those into decimals gives me 0.2601 and 0.1282. So this is the risk of not achieved for snorers. And this is the risk of not achieved or not achieving for non-snorers. So when we do a relative risk calculation, we take one of these and divide it by the other. Now, I usually do it by taking the top number, the big number, divided by the little one. So in here, we get 0.2601 over 0.1282. That works out to 2.029, or about 2.03. We need to interpret that in context, right? So we have to estimate how the risk compares for those who snore and those who don't. So a statement like this: a snorer is twice as likely, well, really, more precisely, 2.03 times as likely to fail the exam as a non-snorer, or about double as likely. Right, sorry for the very bad handwriting. There you go. So that's the first two parts done. Now I think they were both merit parts. Let's have a look at the schedule quickly. Yep, they were. Okay, so going on to the next bit, we have another thing introduced here. So for students who snore, 32% of them do all of their homework. This is a really boring question. For students who don't snore, 65% complete all of their homework. And we're supposing that 3 students are chosen at random from a large group of Year 13 students. Now that's important. The large group is important, and it's a signal that we don't care about whether we're putting the name of the student chosen back into the hat. In other words, it doesn't matter that we're doing sampling without replacement. If you're in my class this year, we haven't actually gone through that in class yet. That's one of the things I was planning on doing today if I hadn't been away. But we can do this problem anyway. So we have to figure out the probability that all 3 Year 13 students don't snore and always do their homework. So the obvious place to start is the probability that one student doesn't do that, doesn't snore, and always does homework. I'm going to do this with a tree. And on the first branch, we're going to put, do they snore or don't they snore? We get these, well, we're going to take these from our table. Now, it's not the same group of Year 13 students. So when we come down to the second part, which is to talk about assumptions, this is something we might want to pick up on. So we're going to say, let's assume that that probability of snoring is equal to the same as it was before, so 123 out of 201, and we had 78 out of 201 who didn't snore. And then we're given this information for the next bit. So we want don't snore and always complete all of their homework tasks. So do all their homework is 0.65. So we don't need to fill out the rest of the tree. So the probability of don't snore and always do homework is 78 out of 201 times 0.65. And some of you won't have bothered to do a tree for that, and that's fine, as long as you're thinking really clearly. But I find that it really does help me to put the tree down to make sure I'm not missing anything. So that gives me a probability for one student of just over a quarter, 0.2522. I've done that and I haven't rounded it for the next part, so your answer might be a tiny bit different from mine. So now we're thinking about the probability that if I choose 3 students, what's the probability that all 3 are like that? So now you can think about a tree again. First student, second student, third student. And you can see that all we have to do is to take that probability and cube it. And that gives me a very low number of just over, or just under 2%, so 0.016. Okay, so that part of the question gets you up to merit, but it doesn't finish it off, because what's important are the assumptions that we have to make for this to hold up. And you had to give, I think you needed to give 2 assumptions here to get excellence. So let's have a look. I'm going to write some of these out before we look at the schedule. So you can pause and look at the schedule, but I want to talk about the ones that I would have picked on if I was sitting in the exam. So actually it's only one assumption for excellence. So let's just go back and read it carefully. The first thing to note is that the 3 students were chosen at random from a large group of Year 13 students, not the same group of students that we had back up here. Okay, so this was just for 200 students. You can reasonably assume that this is for more than 200 students. And the second thing to notice is that the sample was random. So what would I have said here? Well, the first thing I would have talked about was the large enough group. So we're assuming that the group is big enough that the impact on our probability estimate of sampling without replacement is very small, or a good word for very small is negligible. Okay. And because this group is not the same group as the 100 and 201 students, we're also assuming that the percentage of snorers in the second bigger group is, if not the same, then at least similar to that in the first group. Now in the schedule, they've said that we also could talk about, and they'd give you marks for this, they've also said that we are making an assumption that the snoring or homework students of the 3 students are independent. I think it's been generous to have that as a separate assumption, and here's why. We were told in the question that 3 students were chosen at random from a large group of Year 13 students. So if they're chosen at random, we can already assume that their homework habits are independent. If we weren't told they were chosen at random, it would be a really good thing to write about, right? Because if you just pick 3 mates at morning tea or interval, then chances are that their homework habits might be similar. right? That might not be. Their snoring habits are unlikely to be linked unless there's a